So we've been working on plotting graphs, and we've plotted these three graphs. The red one we plotted last lesson, which is just a nice simple one, y is equal to x. And I just showed you that whenever we did the coordinates on a different lesson, on a different board. So don't forget how I'm doing all these coordinates. And now we're using that to plot these graphs, and for that we're coming up with these equations which relate our y coordinate with our x coordinate. Now in the red line, we're simply saying that the y coordinate is equal to the x coordinate. So when x is 1, y is 1. When x is 2, y is 2, and so on. Sounds nice and easy. If we have something a little bit more complicated, like y is equal to 2x plus 2, we might find it helpful to write out these tables and write all the coordinates for x. So on our graph, it goes from -5. Oh, it actually goes to +6. But anyway, we just did to +5. And then we have to work out what x would be in each case. So we just did a few of them. We did, I think we started off with x is equal to 2. So when x is equal to 2, y is equal to 2 times 2, because instead of x, we're writing the value for x, and the value for x in this case is 2. So 2 times 2. A little bit confusing because we've got all these 2's, but hopefully the highlighting makes sense of that. So you do 2 times 2, which is 4, and then plus 2, so that gives us 6. So that's what we write there. Then we did when x equals 3. So y is equal to 2 times 3 plus 2. We're just subbing in the value into here. Wherever it says x, we write the value for x, which in this case is 3. 2 times 3 is 6, and then plus 2 is 8. So we did that with a bunch of them, and then we started to notice a pattern, and that is that it's going up in 2's. So we realized that how to do some of the ones, but we worked out quite a few, and then we noticed a pattern, and we tested our theory out, and yes, it does always go up in 2's, and so we filled it in like that. And then we had to go this one down here, y is equal to 3x plus 5. And this one, we did a different method. I actually did it this way around first. That's a bit confusing, isn't it? Let me just get rid of... Let me just get rid of the highlighting for the moment. I won't bother talking about the highlighting. Let's move this down here. So this time we realize kind of the pattern. What we've done is that y is equal to 3x plus 5. So we worked out what 3x is, and then we added 5, which means another way of doing this is you can do a whole other row where we just work out what 3x is. So, and we can see that goes up in 3's. And when we add 5, we just add 5 to this one. So minus 15 plus 5, minus 12 plus 5, minus 9 plus 5, minus 6 plus 5, and so on. And we notice that goes up in 3's as well. It only goes up in 3's, or the other one goes up in 2's, if x is going up in 1's, okay? Later on, we'll understand that this is related to something called the gradient. For now, we'll just briefly point out that the red line is the least steep. The purple line, which is y equals 2x plus 2, is steeper. And the green line, y equals 3x plus 5, is even steeper. So this number before the x gives us an idea about how steep the line is. But we won't go into any more detail after that. So what we're going to do next is try to understand some patterns with the equations and the graphs. And we're going to use something called Desmos. And that's going to help us to plot it more automatically. We need to know how to plot it manually, like we just did today. But after that, we want to try to identify the patterns so as we can plot it automatically and quickly and work it out from there. Okay.